Today's lesson, we're going to look at acid-base reactions and talk a little bit about conjugate acids and bases and how they play a role in Bronsted-Lowry acids and bases. So an acid-base reaction is pretty simple. We're basically just passing a proton from one molecule to the other. And the molecule that donates the proton is an acid, and the molecule that accepts that proton is called a base. And so in this homework assignment, you have to identify the acids and the bases, but then I'm going to throw in some more terms here. The conjugate acid is an acid that forms when a base gains a proton, and the conjugate base is a base that forms when an acid loses a proton. So let's just take a look at this example here and figure out our acids and bases. That's the easiest. So here I have NH3 plus H2O, and I get NH4 plus OH. So it's pretty clear that my water molecule is going to donate a proton to NH3 to become NH4. So my donor or my giver is water here. So I'm going to identify my acid, and this would be my base. Now if I take a look here, it says an acid that forms when a base gains a proton. Well, this was the base, and it gains the proton, so my NH4 would be considered the conjugate acid. And down here, my conjugate base is a base that forms when an acid loses a proton. So my water lost a proton to become OH, which is a hydroxide ion, which is basic or alkaline. So there's my conjugate base. So my acid became a base on the product side, so we call it the conjugate base. Let's take a look at another example. NH4 plus OH yields NH3 plus water. So my NH4 becomes NH3. That means it lost a proton. So it donated a proton. So my NH4 plus is considered an acid. And my OH, which accepted that proton, I guess I forgot to do the arrow here, which accepted that proton becomes H2O. So if it accepts a proton, it's considered a base. Now what's my conjugate acid and my conjugate base? So a conjugate acid is an acid that forms when a base gains a proton. So OH plus an H is H2O. There's my conjugate acid. Conjugate base, a base that forms when an acid loses a proton. So here was my acid. It lost a proton. NH4 becomes NH3. There's my conjugate base. So that's what you're doing in your homework assignment today, is identifying acids and bases as well as their conjugate pairs. Now, strengths of conjugate acids and bases, basically the stronger an acid is, the weaker its conjugate base will be. And the stronger a base is, the weaker its conjugate acid. Pretty self-explanatory. Your book has a table very similar to this one. So just know that the stronger an acid is, the weaker its conjugate base is. Now, some substances can act as either acids or bases, and we call them amphoteric. So any species, any substance that can react as either an acid or a base, water is the most common. Here in this example, water acts as a base because it accepts a proton from hydrochloric acid to become H3O. But it can also act as an acid, in this case with NH3. NH3 becomes NH4, which means it got this proton from water, and water becomes OH. So water can act as an acid or a base dependent on the other substance it's with. So we call it water and amphoteric. And the last thing I want to discuss is neutralization reactions. Neutralization reactions produce water and some type of salt. So here's a neutralization reaction with hydronium and hydroxide to yield water, but no salt, okay? That's probably the only exception. But here, hydrochloric acid plus sodium hydroxide yields salt and water because this H goes to the OH group, and this Na swaps places with it to become NaCl. So antacid tablets neutralizes stomach acid, producing magnesium chloride and water. So here we go. Your homework assignment is going to look very similar to what we just did here on this first slide. So identify your acids and bases, and then look at that definition to figure out what would be your conjugate acid and your conjugate base.